Hi friends, today we will solve few problems that is as soon as SSC JE Electrical in the year of 2017. Okay friends, now we will solve the first question. Determine the value of charge stored in a capacitor that is in millicoulomb. Okay, we need to find the value of charge stored in the form of millicoulomb. Okay, in the capacitor when the value of capacitance is 0.01 millifarad and the potential difference between the ends of the capacitor is 20 volt. Okay, this is the question. Okay, now we will solve the problem. Okay, now we will write the given what are the parameters given in the question. First one. Okay, here they given the value of capacitance as 0.01 millifarad. Okay, C is equal to 0.01 millifarad. Okay, next the value of capacitor is the potential difference between the ends of the capacitor is 20 volt. Okay, now the value of voltage is equal to 20 volt. Okay, now we need to find the value of charge that is stored in this capacitor. Okay, that is the question in millicoulomb. Okay, now we will solve the question. For this question we have in the direct formula, that is C is equal to Q by V. Okay, this is the formula. So here we need to find the value of the charge, which is nothing but Q. So this formula can be rewritten as Q is equal to C into V. Okay, so the value of C is 0.01 into 10 to the power of minus 3, which is nothing but the milli, into the value of voltage is 20 volt. So if you multiply this both, we will get 0.2 into 10 to the power of minus 3, which is nothing but 0.2 millicoulomb. Okay, here the 10 to the power minus 3 is nothing but the milli. So we can be written as charge is equal to 0. millicoulomb. Okay, this is the answer. So the answer is option 1, 0.2 millicoulomb. Okay, now we will solve the second problem. Determine the value of current in amps drawn from a 8 volt battery when the wire of 24 ohms resistance is stretched double its original length and then cut into two equal parts, and these equals are connected in parallel with the battery. Okay, now we'll solve the question. Here we need to find the value of current that is drawn from the 8 volt battery. Okay, so here see, we need to understand these lines very carefully. Okay, this is the very important line. This we need to understand what it is. That is, see, consider this is the conductor. Its resistance is 24 ohm. Now this is stretched into the length is, while stretching the length of this conductor is getting into double. Okay, consider this is the 1 meter. So after stretching, it is now elongated to 2 meter. Before stretching, the width will be maybe, for example, consider this is 20 centimeter before stretching. Now after stretching, the width is reduced to 10 centimeter. Okay, see, we know the concept, that is the value of resistance and the length is directly proportional. That is, when the length increases, resistance also increases. Okay, and similarly, and the relationship between the area and the resistance, that is, resistance is inversely proportional to the area. Okay, this is the concept. These are the two concepts. So here, now after stretching this, the area is getting reduced and the length is increased. So while stretching, the area is getting into reduced. So for this, so see, I am writing here Now the width of the conductor is reduced to 20 centimeter to 10 centimeter. So we know that the resistance and the area is inversely proportional. So when this area is reduced, its resistance value is also is getting doubled. So now that is, see here, now the width of the this conductor is reduced from 20 to 10. That is off that is almost half of the length is reduced. Okay, so when it is reduced, its resistance value also get double. So because here now the width is reduced, so the area and the resistance is inversely proportional. So while it is getting reduced, the resistance value will also getting double. So 48 ohm. So during this time, the length also getting increased, that is doubled. So totally 48 ohm and 48 ohm. By adding both, it is 96 ohm. Now the total resistance value of this conductor is 96 ohm. So this we need to understand very carefully. So now the total resistance is 96 ohm. Okay, after stretching this conductor, now the value of resistance is 96 ohm. Okay, please understand these two concepts, that is resistance is directly proportional to length and inversely proportional to the area. If you understand this, you can get to know how it is converted from 24 to 96 ohm. Okay, finally we got the conductor with 96 ohm. Okay, after that, and then cut into two equal parts. So then it is cut into two equal parts. So 1 and 2. So this is 48 and this is 48 parts, and these equals are connected in parallel. So these two resistance, the dissected conductors are connected in parallel. So these two are in parallel. So if these two conductors are connected, these two resistors are connected in parallel, mean you will get, that is for resistance in parallel, R1 into R2 by R1 plus R2. So is equal to 48 into 48 by 96. So 1, 2, 24. So now the total resistance is 24 ohm. This is the effective resistance after stretching the length, and it is cut into two equal pieces. So now the value of resistance is 24 ohm. Now we need to find the value of current. See, now we got the value of resistance and the value of voltage is 8 volt. Now we need to find the current. We having the direct formula, this I is equal to V by R. Okay, now the value of voltage is 8 by value of resistance is 24. So if we solve this, 8 1 8, 3 is 24, this 0.333, the answer is 0.33. So the answer is option 1, 0.33 amps. Okay, this is the answer. Okay, now we will solve the next problem. Okay, determine the heat in joules dissipated through a resistance of 15 ohm resistance when 0.5 amps of current is flowing through the resistor of 8 in 8 seconds. Okay, we need to find how much energy that is in the form of heat that is dissipated in this resistance when 0.5 amps of current flowing through the resistance for 8 seconds. Okay, now we will write the given parameters. Okay, first one, the value of resistance is 15 ohm and the value of current is 0.5 amps and the value of time is 8 seconds. Okay, that is 0.5 amps of current is flowing through this resistance for 8 seconds. Okay, now we need to find how much energy in the form of heat in joules is dissipated while the current is passing for 8 seconds. Okay, this is the question. Okay, for this we having the direct formula, that is H is equal to I square RT. Okay, I is nothing but the current, so the value of current is 0.5 into resistance is 15 ohm into time is 8 seconds. So if we multiply this, we will get 8 piece of 0.25 into 40, sorry, 20. So if you multiply this, you will get 3,000. So sorry, 3,000. So if we take this decimal point, we will get 30 joules. Okay, this is the answer. Since we are having the direct formula, that is the formula for the heat transfer, that is H is equal to I square RT. Just we need to substitute the values given in the question. So if we substitute this value in the formula, we will get the final value as 30 joules. Okay, please. So the answer is option 2, 30. Okay, now let's solve the next problem. Okay, what will be the potential difference between the ends of the conductor when the current flowing through a conductor is 3 amps and the value of conductance is 0.3 mho? Okay, this is the question. Here we need to find the potential difference. Okay, between the ends of the conductor when the current is flowing through the conductor is 3 amps and the value of conductance is 0.3 mho. Okay, so now given is I is equal to 3 amps, the conductance is 0.3 mho. So friends, here the value of amps, which is nothing but it is a charge, and the conductance is nothing but the capacitance value. Okay, because we are having the formula C is equal to Q by V. Okay, this is the formula. Just we need to substitute the values. So Q is nothing but the value of current 3 amps by we need to find the value of potential difference. So V is equal to Q by C. So the value of current charge is 3 by value of the conductance is 0.3. So if we solve this, 1 by 0.1. So if we take this into numerator, the values will be 10 volt. Okay, this is the answer. So the value of the potential difference is 10 volt. So the option is 1, answer is 10 volt. Okay, I will solve the next problem. Okay, determine the value of current in amps that flows through a resistance of 9 ohm when the potential difference between the ends is 36 volt. Since it is a direct question, using the Ohm's law, we can solve this in short duration of time. So the given is R is equal to 9 ohm and the voltage is 36 volt. We need to find the value of current. So I is equal to V by R. So 36 by resistance is 9. So the answer is 4. That is 4 amps. So the value of current is 4 amps. So the option is 3, 4. Okay. Okay friends, that's all about today's video. Next video we will solve many problems that is asking SSC JE. Okay, thank you.